Okay, Algebra 2 students, it's time to address the following situation. So I'm going to give you a few minutes to see if you can determine the phrase that that this picture represents. So give yourself a moment. Okay, we can do a little hangman, if you will, a little wheel of fortune. See if you can determine what the picture represents with respect to quadratic functions. Okay, take a couple moments. All right, good enough. You can pause the video to see if you get bonus points if you can figure this out. Going to the next page, and I'm going to reveal what I'm talking about here. You'll see what a good sketch this is. If I go to this, bam, the elephant in the room. Oh, that's a nice picture there, Lee, that represents an elephant in the room. And with respect to quadratic equations, solving quadratic equations, the elephant in the room is what's happening here. If I have this quadratic equation, for an example, this guy right here, 3x squared plus 2x plus 1, and I go to find the discriminant, I see that the discriminant is -8. So the discriminant is indeed less than 0. So what does that tell me? That tells me that there are no real solutions to this equation right here. But what there are solutions, not real solutions. We keep talking about real numbers. We've discussed real numbers multiple times in this class. And you may or may not have introduction to what we call non-real numbers. And non-real numbers are called imaginary numbers. These are the non-real numbers. And there's whole disciplines called complex analysis, which analyzes complex numbers. A complex number has a real part and an imaginary part. All we're talking about today is the imaginary part. And what is the imaginary number? The imaginary number, is it on this page? It must not be on this page. The imaginary number is this guy right here, I. I, which stands for imaginary. It's not a real number. It's an imaginary number. What the heck is I? Well, I is very simply the imaginary number. But we have this, the definition of I is such that if I square I squared is equal to -1. And what you need to understand is that any real number squared, if I talk about any real number A, if A is a real number, could be negative, could be positive, could be anything, but if A is a real number, this is for certain, A squared is greater than or equal to 0. That's why we need this imaginary number, because if you look here, if I square the imaginary number I squared is going to be -1. How is that going to be useful? It's going to be useful because of this notation here. If I squared is -1, then the square root of -1 is I. So both of these could be called the definition of the imaginary number I. I squared is -1, and I'm going to put a double arrow there, if and only if the square root of -1 is equal to I. We will talk much more about the imaginary number, but it's going to be enough for us today to realize that the square root of -1 is I. How is that going to help us? Well, here's how that's going to help us. If I go to a previous problem that I've talked about before, the previous problem I was talking about, the solution to this 3x squared plus 2x plus 1 is 0. I get the discriminant is -8. Well, if I put this discriminant right here, if I put that into my quadratic formula, then my solution comes out to be -2 plus or minus the square root of -8 right here. Well, first and foremost, this is not real. This is not real, but it is an imaginary number. And what we're going to do is we're going to simplify this guy here we're just going to look at this part right here, the square root of -8, which is equal to the square root of -1 times the square root of 8. And hey, what is the square root of -1? The square root of -1 is I, square root of 8. So that's what this dude is. The square root of -8 is I times the square root of 8. And all that does is give me a nice, correct way to write these solutions. And how am I going to write those solutions? I'm simply going to write, well, here's the first solution. -2 plus the square root of -8 over 6. -2 minus the square root of 8 over 6. And if I just simplify this square root of -8, i.e. take the negative out, it's just going to be this. It's going to be -2 plus I square root of 8 over 6, -2 minus I square root of 8 over 6. Okay, so all I'm doing is taking the square root of a negative and writing it in terms of I. How am I writing it in terms of I? I'm using this definition right here. I'm using this part of the definition. So is this going to be significant? Oh, heavens, yes. Oh, heavens to Betsy. And you should have been asking yourself all along, what about the square root of this negative thing? And that should have been an elephant in the room. Something that's weighing heavy on your mind. So we're going to do one more example here. Bam. All right. Let's find the solutions to this equation, and let's simplify this using the fact that the square root of -1 is I. Here we go. So I have this guy right here. I know A is 1. B is -1. C is 1. I know my discriminant O is -3. I've actually done this problem before in class or in one of the Google Meets. So I have B squared, which is -1 squared, for AC, -4 times 1 times 1, and that's going to be -3. Therefore, the solutions to this equation, and what do I know? There are no real solutions, but there are imaginary solutions. And what are those imaginary solutions? Right here they are. Negative b plus or minus square root of -3. Square root of -3, friends. All I'm doing is writing that as I square root of 3, I square root of 3, and it's going to be -1, which is 1, plus I square root of 3 divided by 2a, and 1 minus I square root of 3 divided by 2. Okay, using this fact right here. So not too heavy, but fairly heavy. Heavy enough to, yes, indeed, to call this an elephant in the room. All right, so I'll let you copy this one down. So henceforth, what we're going to do, if we have a quadratic equation that has imaginary solutions, I do indeed, students, want you to write them using the number I, the imaginary number I. So that's it for this little lesson. I will post this and you shall watch it, and I bid you farewell.